Okay, this is your test review video part 1. So this is the second test that we're taking in our semester, and the topics covered on this test are density, the calculations, and you need to know significant figures when you're doing those calculations, parts of an atom, reading the periodic table, elements and the properties and their trends in the periodic table, chemical bonds, and then how to write ionic compounds, names, and formulas. You will be able to use a calculator on this test. You'll be able to use your periodic table, and you will be able to use the ionic bonding puzzle pieces if you would like to use those on the test. Nothing else is going to be available to you while you're taking the test. Okay, in this video, I'm just going to be covering density, how to do those calculations, and how sig figs are important to that. First, I want to ask you, what is heavier, 1 kilogram of feathers or 1 kilogram of steel? And for reference, 1 kilogram in American units is about 2.2 pounds. Probably know, you've probably heard this before, that 1 kilogram of steel and 1 kilogram of feathers, they have the same weight or the same mass, but because steel is way denser, it's going to take up way less space. The feathers take up way more volume than the steel. So that is what we're talking about when we talk about density. It's how packed the molecules of a substance are. The more closely packed those molecules are, the more dense that substance is. There were 3 equations that we went over about density. There's density is equal to mass divided by volume. Volume is mass divided by density. And mass is equal to density times volume. I will give you those equations when you're taking your test. You don't have to have the equations memorized. What you do need to know, though, is that mass is measured in grams, and that's G for short. Volume is measured in milliliters, ml, and density is measured in grams per milliliter, G/ml. That part you do need to memorize. The formulas you do not need to memorize. Okay. This is going to be a quick review of significant figures, and then we'll do some examples of density calculations where we make sure that we have the correct sig figs in our final answers. So remember that all non-zero numbers are significant, so that's numbers 1 through 9. Remember all zeros that are between sig figs are significant, and so that's like if you have 101, the 0 in between there is significant. If you have 100 or 1,020, well, the 0 that's between the 1 and the 2, that one's significant, but this one's stuck on the end. It's not significant. So remember, all zeros at the end of numbers are significant only if there's a decimal point. There's no decimal point in this number, so that's why this 0 on the end isn't significant. If we rewrote that as 1020.0, now those zeros on the end are significant. And so this would be a total of 5 sig figs. All of those would be significant. If we just wanted it to have 4, we could write it like this, 1020 with the decimal point there and then no zeros behind it. That would be 4 sig figs. The last thing is zeros before the first non-zero number are not significant. That's those placeholder zeros like 0.00001. All of these zeros are just placeholder zeros and they are not significant. They don't get counted. But then anything that comes after that first non-zero, those get counted. So because all of these zeros after here are coming after that one, they all get counted. And so that's where putting spaces in here can kind of help. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8 sig figs. Just those are going to get counted. Okay. You guys have, this was from that first video that we watched at the beginning of the semester, where we talked about in Rule 2, zeros between sig figs, those are significant. This one doesn't have anything on the end, so those are not significant. Significant in between, not significant on the end. Then if there's no decimal point, we don't count that zero. And then once there is a decimal point and we added a zero after it, both of these zeros are getting counted. Same thing here, yes to both of these zeros, yes to these in between, but not to these trailing zeros. And then to those zeros before that first non-zero, this zero that comes before, not significant. The one that comes after the decimal point, or after the numbers have started, is significant. Here, none of these zeros are significant because all of them are before the first non-zero number. Okay, and last one, the zeros that are before the 9 are not significant, but the zero after is significant. If you are still struggling with sig figs, go back and watch that first sig fig video again, and it'll give you more examples that you can practice with. So then, density calculations and significant figures. So this is where we'll actually apply this to some scenarios. First we have, you measure out 25.0 milliliters of water, and then you weigh it on a scale. The scale reads 25.00 grams. What is the density of the water? First thing that I want you to know is that the 25.0, that number, the volume, has 3 sig figs. And then the 25.00, that has 4 sig figs. Our answer must have the same number of sig figs as whatever our smallest value of sig figs in the problem has, and that's 3. Our final answer can't have 4 because then that would mean that this would have to be more significant. We can only go with the smallest number of sig figs, so that's why the answer has to have 3 sig figs. Now let's actually perform that calculation. So density is mass divided by volume, and here the mass and the volume are actually the exact same because that is in fact the density of water. The density of water is 1, which is on purpose. That's the standard density that we compare all other densities to. Water is 1, and then everything else gets compared to water. So that's 25 grams over 25 milliliters, so 1 gram per milliliter, and it needs 3 sig figs, so we put the 2 zeros there after a decimal point. Okay, example 2. Now we are going to calculate volume. So you need 350 grams of salt for a recipe, and you know that the density of salt is 2.16 grams per milliliter, which is the actual density of salt, of like NaCl, sodium chloride salt. What volume of salt must you measure out to have enough? First of all, let's take a look at those sig figs. The mass, 350 grams, only has 2 sig figs. And then the density, 2.16 grams per milliliter, that has 3 sig figs. So that means our final answer has to have the smallest number, which is 2. So then when we do this calculation, volume is mass divided by density. So the mass goes on top, 350, divided by the density, 2.16. And when you type that into your calculator, you get a whole big old number. So 350 divided by 2.16 gives me all of this stuff. We have to round it off so that it just has 2 significant figures. So you're going to round it off after the 6. And so if that's a 2, then we're going to keep the 6 the same. Okay, 5 or below 5, so 4 and less, we're going to keep it the same, and then put the 0 there. Last example for you for this video is a silver cube has the dimensions of 3 centimeters by 3 centimeters by 3 centimeters. Before we can do a density calculation with this, we need to know what that volume is, and that's where you would do 3 times 3 times 3 gives us 9 centimeters cubed. And remember that centimeters cubed is the exact same thing as a milliliter. They're defined to be the same amount of space. Silver has a density of 10.49 grams per centimeter cubed. What is the mass of this cube? So first, we know 10.49, that has 4 sig figs. 9.00 has 3 sig figs. Our final answer must have 3 sig figs because that's the smaller number. And now for our calculation, we're going to do mass is density times volume. And so when you plug that into your calculator, you get 10.49 times 9 gives us 94.41. And so 94.41 is the answer from your calculator, but you can only have 3 sig figs, so our final answer is 94.4 grams. All right, that's it for this clip. For the rest of your test review, watch the next one. Thanks.